Cool thing about LLMs is that they are not constrained by the human learning style of specializing and going very deep into one area. So a sociologist might not know much about big O notation, but I asked ChatGPT for a sociological critique of big O notation, and it came up with this. It's pretty good. I'm going to read it. Big O as legitimacy theatre, signalling and cultural capital. Thesis: in contemporary hiring education, Big O often functions less as a practical engineering tool and more as legitimacy theatre. Hey, let's go all the way into the AI land and have
Big O as legitimacy theater, signaling, and cultural capital thesis. In contemporary hiring and education, Big O often functions less as a practical engineering tool and more as legitimacy theater, a ritual that signals belonging and competence to gatekeepers, regardless of whether it predicts on-the-job effectiveness. Its persistence is explained by signaling theory and Bourdieu's notion of cultural capital more than by empirical relevance to everyday software work. Legitimacy theater, the ritual that reassures institutions. Organizations need a selection process that looks rigorous, scalable, and defensible. Big O puzzles are easy to mass produce, auto-grade, and standardize across geographies and interviewers. They satisfy compliance and fairness optics. Same question, same timer, numeric score. This makes Big O a performance of objectivity. Whether candidates will spend their days optimizing asymptotics is secondary. What matters is that the institution can point to a neutral-looking filter. The ritual persists via institutional isomorphism. Once marquee firms do it, others copy it to inherit their aura of rigor. Signaling theory, the costly badge. From a signaling perspective, Spence, success on Big O problems is a costly signal of general
this is
ability,
Spence here, the economist.
time availability, and familiarity with a specific academic style.
You got Nobel
It's
Prize.
expensive to acquire. Months of leak code reps, CS curricula, the right textbooks, but cheap to verify, a number on a dashboard. Because the signal is costly, it separates populations, those with the time and training to master algorithm drills from those who learn by shipping code, maintaining systems, or self-teaching. The signal says more about test prep capacity than about debugging skill, product sense, or collaborative engineering. Cultural capital. Who knows the script Bourdieu would call Big O fluency a form of cultural capital?
Bordeaux, he's the French
The
one.
tacit knowledge, language, and dispositions that mark insiders. Knowing how to turn a messy problem into find the smallest missing positive with a one space is a habitus, a way of talking, diagramming, and arguing that maps to elite CS education. Candidates from non-traditional paths, boot camps, ops, data, self-taught, may have rich practical capital, observability chops, API literacy, systems intuition, but lack the legitimate capital recognized by the field. Big O becomes a shibboleth. It filters for your ability to speak the dialect, not to do the job. Goodhart's law, when the measure becomes the target, once Big O interview performance becomes the metric, candidates optimize for it. They memorize patterns, two-pointer, heap, union find, practice time-boxed coding, and learn to name complexities on cue. The result is selection for test-taking virtuosity, rather than for engineering fundamentals like reading unfamiliar code, taming flaky builds, simplifying designs, or making trade-offs under uncertainty. Teams then inherit developers who can invert trees on a whiteboard, yet struggle with messy integration work, the core of real software engineering. The mismatch with day-to-day engineering. Most professional Python.js work is constrained by I/O, network latency, database shape, cache behavior, and library choices, not raw asymptotics and isolated arrays. Performance wins often come from using the right CBAC primitive or data store, not hand-rolling O1 space tricks. Meanwhile, reliability is dominated by logging, tracing, tests, and operational maturity. Big O drills underweight these and overweight an abstract model. Unit cost RAM, infinite N, uniform primitives that rarely governs day-to-day outcomes. Why it sticks anyway. Cheap scalability, easy to grade thousands of applicants. Status inheritance, we hire like the prestige firms. Legal comfort, standardized questions feel safer under scrutiny. Managerial legibility, a single score is easy to sort and justify. The social cost, exclusionary tilt, rewards those with time and resources to acquire the right capital, penalizes career switchers, caregivers, and self-taught engineers. Talent misallocation, filters out practitioners strong in debugging, system sense, and product impact. Cultural narrowing, reinforces a monoculture that equates real engineer with a narrow academic performance. A better norm, still rigorous. If rigor is the goal, use signals that measure work you'll actually do. Work sample tests, small features bug fixes with real repo layout, tests and docs. Pairing sessions. Read an unfamiliar API, write a test, add instrumentation, discuss trade-offs. Structured rubrics. Clear criteria for correctness, clarity, collaboration, and pragmatism. Complexity as a guardrail, not a cudgel. Ask candidates to spot a quadratic footgun in a code review rather than to perform asymptotic theater. Steelman, brief for completeness. Big O is not useless. It prevents catastrophic choices at scale, gives shared vocabulary, and matters in domains where asymptotics do dominate. Infra, databases, compilers, ML systems.
It's a cudgel.
But those benefits don't justify using Big O puzzles as the primary hiring filter for roles where day-to-day success hinges on different skills. Bottom line, in current practice, Big O interviews often function as legitimacy theater, a convenient, prestige-laden signal of cultural capital, more than as a valid proxy for engineering effectiveness. Keep Big O as a safety rail for bad complexity, but stop treating its performance ritual as the gold standard of software talent.
That's pretty good. Yeah, it's gone straight for the jugular. I love the cultural elements of it. The narrow academic world. You don't really learn anything at university you can't learn in the real world. Maybe if you're a medical doctor, you should go to university, but I like this concept of social capital, that it's a gatekeeper. Habitus, I don't know what that is. I mean, I know habit is a house. In sociology, habitus is the way that people perceive and respond to the social world they inhabit by way of their personal habits, skills, and disposition of character. People with a common cultural background share a habitus as the way that group culture and personal history shape the mind of a person. Consequently, the habitus of a person influences and shapes the social actions of that person. The sociologist, here he is again, Pierre Bourdieu, said that the habitus consists of the hexis, another thing, a person's carriage, posture, and speech accent, and the mental habits of perception, classification, appreciation, feeling, and action. The habitus allows the individual person to consider and resolve problems based on gut feeling and intuition. Influences the availability of opportunities in life, and thus the habitus is structured by the person's social class, but also gives structure to the future path available to the person. Therefore, the reproduction of social structures results from the habitus of individual persons who compose the given social structure. So I hadn't heard of him before. I then went and asked ChatGPT, what's the connection between him and Foucault? There's not really a lot. So Foucault I've studied, but not Bourdieu. So Foucault explains how institutions produce compliant subjects, whereas Bourdieu explains why certain groups keep winning inside fields via capital and habitus. There is habitus again. This line, abstract model, unit cost RAM, infinite n, uniform primitives. I mean, that's the real problem with all these HackerRank things. They're very much based on a kind of 1970s view of the world. Maybe earlier than that, 50s. You stick your algorithm on punch cards, and it goes into the system, and it's run the same way regardless of what it is. Whereas in a modern world, as it says, the more important things are input, output, the network, the database, the cache, and whether you have C primitives or not. So a lot of these give the best Big O notation version, actually give a slower version by the wall clock. As we saw in the other video, what makes it actually fast and what the Big O notation are often not correlated, because the model, the academic model of the Big O notation is too simplistic for our modern cloud-based complicated world, and it's wrong more than it's right. So how useful is it as a tool? Yeah, it's controversial stuff. Give me your thoughts, what you think about this. Tell me what you think. Do you disagree? Is this sociologist, virtual AI sociologist, completely wrong about this? Let me know in the comments. Shout at me on Twitter. That was fun.